So let's understand what is Docker and how Docker Docker. So Docker, as you know, it's a containerization tool. So wherein it enables you to create containers. You can create and manage the containers using Docker. Let's understand how Docker works. To understand how Docker works, we have to understand Docker architecture. So we have to understand Docker architecture. So let's understand the Docker architecture. In Docker architecture, majorly we have three components. So that is Docker client. So that is Docker client. Docker client, then Docker host, Docker host, then Docker hub. That is nothing but Docker registry. So Docker registry. Docker registry. So what is this Docker client? See, Docker client is a command line interface from where you can communicate with the Docker. So this Docker host is the main component. So wherein it runs a daemon, DA. Okay, it runs a daemon. So it runs the daemon. Then all the containers. So whatever the container we run in Docker host. Now let's say I want to run a container. So what I want to do, I want to run a container. How can I create a container? So now let's say you want to build a house. Okay, so how do you build a house? What is the procedure?
First, we need to build the base.
You have to build the base. Okay, then
Then
We need to um, buy the stuffs to build the
raw material.
raw materials, correct? Yeah.
raw materials. Okay. Okay, so now today you'll talk to your home, then tomorrow you will buy the raw material, and day after tomorrow you will start building home. Isn't it? uh, okay, so there is a small part missing first. Okay, so when you have a discussion of building your own house, it's a dream house, right? So obviously everybody's dream is to have their own house, whether it is small or big, irrespective of that, right? So what you do first, you will build a blueprint. Am I correct?
Yeah.
Yeah.
Do you build a blueprint or not? Yes. Obviously, you
Yes.
build a blueprint. Who will create the blueprint for you? I mean, blueprint that maybe a 3D animation. It could be just a simple plan, 2D plan, right? Who will build it?
The architect, the engineer.
The engineer, the architect, maybe civil guy, the civil architect, right? So now you give your requirements. You will say, this is what my budget. This is what my budget. I have 1 crore in this. I need 2 floors or 3 floors. I need villa or bungalow, whatever it is. You give your requirements. According to that, architect will build a blueprint. So now, by considering the blueprint, we'll build the house. Am I correct?
Yes.
Yes.
Now, our container is also nothing but a house. Now, to build the container, to run a container, you need a blueprint, right? So either, if you want, you can create your own blueprint, or you can create, so you can use the existing blueprint. So now, where the blueprints are kept, blueprints are created and managed. So they are managed and saved in Docker registry. So this is the blueprint. These are called as images. What this is called as?
Images.
Images.
Yes.
Are you understanding what is this blueprint? So image is nothing but a blueprint to create a container. So I told you, image, this container will have a source code, will have the OS, will have all the necessary components to run an application, right? So how it runs because of this image. In the image we will mention our source code and everything is packed here as an image. It's a blueprint now. Now how to create this blueprint, we'll discuss that later. Okay,
Okay.
we'll discuss that
Mm.
later, how to create the blueprint. Now blueprint is there in Docker registry. It's like your GitHub, you know, GitHub, or maybe code repositories wherein you get your push your source code, right? Or it could be
Yeah.
SVN.
Yeah. Yes.
Yes, it's like that. So it is a central repository where we manage our images, Docker images. What is this image? Image is nothing but blueprint to create a container. Now how to create a container using this blueprint? So what you do, so you will go to Docker client. So in Docker client you run a command docker pull. First you have to pull this image. First you have to get this image. So when you run docker pull, so the command will request docker daemon will request here and will get the image to docker host. Now this is the image, so we are getting this image to this, where? To docker host. Now image we got, that means you got the blueprint from remote repository, I mean from Docker registry. This Docker registry, it could be a Docker hub, Docker hub, it could be Docker hub, or it could be ECR Elastic Container Registry, or Azure Container Registry. It can be anything. So it's a central repository. So in our case, let's say it's a Docker hub. So we are getting the images from Docker hub. So we pulled it to our local machine. It's like pulling the source code. If you pull the source code, the new changes will come to local machine. Am I correct?
Yes.
Same way, if you pull an image, image will come. You pull an image will come. So that's how it works. Then, so using this image, how to create a container? So to create a container, so you have to run command docker run. So what's the command? Docker run, then you will mention the image name. So you will mention the image name, then go to daemon. Yeah, so go to daemon, then from daemon to select the image, then create the container. Now container will be created. Now let's say this is a container. Oh. So now this is created. Yes, so image, using image, a container is created. Now container is live. So container is the house. This image is a blueprint. So using blueprint we created. Now using the same blueprint we can build multiple houses. Am I correct? Can we build multiple houses using the same blueprint?
Yes.
Yes.
We can build a house for Linta, we can build a house for Sandra, we can build a house for me as well. So you can build a house for your friends, your colleagues, if they agree the same blueprint. Yes, same way, using the image, using this blueprint, we can build a number of containers. We can clone it. This is the use case of the image. Are you understanding? Yes.
Yeah.
So now you got the difference between image and container. Now how to build this? How to build this image? So how to build image? So if you want to build image, first you have to create something called Docker file. So what you have to do? You have to create a Docker file. So Docker file. So what is this Docker file? So Docker file is nothing but The requirement file, you would say a raw file, a raw text file it is. So what it is?
A raw text file.
It's a text file with all the specifications. Let's say what source code you want, then which operating system you want, then what dependencies to be downloaded, what commands to run, what environment to set up. Everything you will be there in this text file. From Docker file we will create Docker image. So what do we do? Docker image we create. So Docker image. Docker image. From the Docker image we create Docker container. So what do? We create Docker container. Docker container. Are you understanding? So first Docker file, first step, then Docker image, from Docker image Docker container. So Docker container, this is where our application runs. Easy?
Okay.
Any confusions?
I didn't understand fully.
So where is your
Yeah, so
yeah, you go ahead, Linda.
no, you told in the Docker container where our application runs, right? So we can able to run application container, like how it is, it will be. We no need to deploy that or somewhere.
So this container will run on server.
Okay.
Okay.
This container will run on server. It's like a mini server only. This Docker container is nothing but a mini server itself. It's a mini server. Within the server you have one mini server. This is also like a computing device. I will show you now, you get more clarity. So just understand.
Okay.
So you have to create a Docker file, then you have to create a Docker image, then you have to create a Docker container. So we have three components. We have three components. Docker client, it's a command line interface. We run Docker commands where we communicate to communicate with the Docker host. And we have Docker registry, that is nothing but Docker hub, wherein we keep the Docker images, we keep and manage, we save and manage Docker images here. Then containers runs on Docker host. Okay, basically these two will be on the same machine. This Docker client and Docker host both will be on the same machine, right? So now you already installed a Docker desktop, correct?
Yes.
Yeah.
So Docker desktop will by default install this both. Already you have installed this. Now this is what your Docker desktop. Docker desktop. So you have installed Docker desktop, right? So this Docker desktop has Docker client and Docker host, which is there in your machine. So let me start my Docker desktop. So it will spin up now. Yeah, so in the left side you can see, can you is it visible?
Yes. Yeah.
So you see there are images. So for you it shows nothing as of now if in your machine, because you don't you did not pull any images. So I have pulled these many images, that is why images are visible here. Can you see this? Yeah, So I have pulled this image, that's why it is visible. For you it shows empty, and under containers also no containers will be running for you. I have created some containers, so it is running here. And we have volume. You can also manage Kubernetes here. You can create your own Kubernetes cluster, local Kubernetes cluster. We have Docker Hub. So I told you Docker Hub, right? Yeah, here you go. This is your Docker Hub. So this is your Docker Hub. So then, okay, now let me show you how you can pull the images. Let's say I want to run a Java Java application. Let's not go for Java application. A static website. There, you know about Nginx? Do you have any idea about Nginx?
No.
Nginx. So Nginx, it's a very popular tool. It's a very popular load balancer. It's a proxy server. It's a proxy. It's a reverse proxy. You can see Nginx. So Nginx is a web server. It's a proxy. It's a web server. Now this is an image. This is a blueprint to run Nginx. It is a software, you could say. It is a software like just running some software. So Nginx is a kind of it's a web server. It will spin up our application. It runs it. You can use it as a proxy. Let's say you are running a .NET application. .NET application is running on port number 3000. Now you want to listen on port number 80, which is HTTP request, and forward it to port number 3000. Are you understanding?
Okay.
Say your .NET application is running on port number 3000. You want to listen port number 80, which is HTTP request, and forward this request to port number 3000. Okay, so that kind of task can be done by Nginx. It works as a proxy, and it also works as a web server. Web server means it serves the web content, index HTML files. It serves the HTML files. Okay, so now I'll show you. So if you want to pull this image, let's say this is an image which is already built image, which is there in my Docker Hub. If I want to pull this image, what can I do? So I have to select which version I want to pull. Let me select which version I want to pull. So I want to pull Perl version. Let's say Perl version. Let's say these are the different versions of the Nginx. So if it is a Java, you will get different versions of Java. These are the different versions of Nginx. So let me say I'll pull Perl version, then click on pull. So you can run commands. Commands I'll teach later. First let's do manually. So manually, if you want to pull this image, I selected the version. This is Nginx, then pull. So this image will be pulled from Docker Hub to local machine. So it is pulling. Can you see this?
Yeah.
So now this will reflect here. So after pulling, so I'll search Nginx here. Yeah, see, it's getting pulled now. Nginx, this is latest version. Can you see this? This is different. Nginx latest is different. This is a different version. I am pulling Perl version. So it is coming up. You see, it is coming up. So we'll take some time. Yes, you can see Perl version visible.
Yeah.
This is just an image. What is this? It is just an image. You can see this is just an image. Now, how to run this? If you want to create a container out of it, this is an image. It's just a blueprint. If you want to create a container out of it, you have an option to run here. Click on run. Optional settings. We have to do some port forwarding. I'll tell you what it is. So observe very carefully. 1 minute of attention here, please.
Okay.
So this is your local machine, right? So inside that you are creating a container. This is a container. This is local machine, big one. This is container. Now the container also, it is also a kind of machine. So what is this? Container is also a computing device, it is also a machine. Now let's say the container is running on port number 80, port number 80 of the container, because this is also a machine, right? For this also port numbers will be there. Okay, this is running on port number 80. Now if I want to access this container, let's say it is a website. What is this? A website,
Website.
web application.
Website.
Okay, it's a web application. Let's say it's a web application, web app. Now if you want to access this web app, you will not be able to access, because this is running as a container and you have no direct access to containers. What you have to do, you have to map this port, this is the container port, to your local machine. So what you have to do, so you have to map the container port into your local machine. So your local machine, I'll call it as a host, and this is container. So container port should be mapped to host port. Host port can be anything, any port, any open port you can mention here. Any open port, it can be 80, 80, 80, 90, 9000, any port number. Let's say here also I will mention 90. Okay, now when you do localhost 90, localhost 90, the request will go where? The request will go to this container. Are you understanding? Are you understand what I am doing?
No.
So I was just telling you. Now let's go in a real time. In real
Okay.
time, you have a house. Now you live in a house. In house there are different rooms, correct?
Yeah.
Different rooms has its own door, right? Room with the door. Now let's
Okay.
say room door number is 80. Room door number is 80, correct?
Okay.
Yeah.
Okay.
Without, how do you enter the room? How do you enter the room? First you should enter the house, right?
Mm.
Yes or no? Without entering the house, how do you get inside the room?
Yeah.
First
Yeah.
you should enter the house, then you should enter your room. For your house, let's say it's a big house, you are a queen now, you have 65,000 doors. 65,000 doors, then just assume how big it is.
Mm-hmm.
That means 65,000 ports are there in your laptop. Am I correct?
Yeah.
So
Yes.
usually there are 65,000 plus ports are there, right? So
Mm.
same way, each and every room has a door. So this door, if you want to enter the room, first you have to define the main door. First you have to define from which main door you are coming from, then only you will get entry.
Okay.
Okay.
Right? You are connecting both the doors now. Okay, gate number 90, you enter from gate number 90, then you will go to room number 80. Are you understanding?
Yes.
Mm.
Now our container is nothing but a room. If you want to go inside the container, you have to mention which gate number in your local machine.
Okay.
Okay.
Are you understanding?
Yes.
Yes.
That is what I am telling now. This is host. Host means your house. Container means your room. Now
Okay.
from the host, which door number is the entry for this container? For this container, for this room, gate number 90 is the entry. Anybody want to go inside the room number 80, I mean this container, web app container, they should come from which gate? Gate number
90.
90.
90. Do we need to use only 90? It is your choice. it is your choice. You can use 90, you can use 80,000, you can use any port number from less than, I mean, available ports, any port number which is available in your machine. Are you understanding?
Yeah.
Yes.
Yeah. So now that is what I'm going to do. So when you click on create container, you get an option. Choose. So click on run. You click on run. So you get optional. Click on optional settings. Container name. You should give a name. So shall I give it as web app? Shall I give it as web app?
Yeah.
Host port. Now tell me host port. What is this host port?
Is the
Main door.
Yeah, gate, main door. So anything you can select. Let me select 90. Next, see, room number is already selected 80.
Okay.
Room number by default selected because it is mentioned in the blueprint. So we did not create this blueprint. Somebody has created it. That's fine. So it's already selected. Which one? The room number is selected. Room door number is selected. You have to select only main gate number. That is nothing but your host.
Like, how do you know this gate numbers before prior? How do you know that? For example, I have given 200. Will that be accepted here?
Yeah, of course.
If there is any scenario that a particular number is
Let's
not
say
defined.
now you are building an application, your .NET application. You know which port number your .NET application runs?
Yes.
Yes or no? Now you have to specify that port number while building the image. While writing this Docker file, I told you this complete process. While writing this Docker file, in the Docker file you have to mention my application will run on port number. Let's say your which port number? Let's give me a random port which you usually use for .NET.
80. 80 is there.
You run .NET on 80. Port number 80. Fine. So now you have to mention it in your Docker file that my application runs on port number 80. Then only you will get to know where it runs.
Okay. Got it.
Let's say my application, let's say Java. So if you're using Tomcat server, Java, which port number usually you use, Linta?
we use 80.
80, same 80.
Yeah.
Yeah, so most of the application we run on 80 only because this is what the port for HTTP, right? This is the HTTP port. So if you're running any port, you have to mention the port number here. Okay, my application runs on port number 8080 or whichever port number. You have to mention that. Then the container runs on that port. So now, since the Nginx image, by default, Nginx runs on port number 80. So already it is selected. Now I'm mentioning my main gate, means my laptop port number, that is 90. Then volumes and the environment variables, I will leave it as of now. We will discuss later. Then click on run. If I click on run, what it does, it creates a container. You see, it created a container. Under container, you can see there is a container called web app, which is running on port number 90. Can you see this?
Yeah.
90:80. 80 means what? 80 is the container port. 90 is the host port. Now this is running. So let me go to my local machine and type localhost 90. Can you see this? This is a website, a small website I deployed. Now in the same way you can also deploy your applications. Okay, let me stop this. What in case if I stop this? Click on stop, come back, refresh. Website not accessible. Why?
Because we stopped.
Start it. Let me start it. So click on this. So it will start. It started. Refresh. Can you see this? Visible?
Yeah.
Come back. these are the logs. Logs, you understand logs, right?
Yeah.
So
Yeah.
these are the logs for this application. So I tried accessing, right? You see get request. Then I stopped it, so it terminated and it started again. See, exit gracefully shutting down. Then this is a Linux. It uses a Linux OS. I mean, it's also a machine now. This container is also a machine. If you click on exec, you get inside the container. You can run Linux commands. Can you see this? Inside the container I am running the commands. This container is also a kind of machine now. Right? Here we have folders, you see, home, MNT, TMP, where, media, optional, root directories, USR. More familiar with Linux, right?
Yeah.
Yeah. So this is a
So
container.
if you want to restart a Docker or something, you can write the same command here in the execute.
It is not to restart the Docker. It is just to restart this container. If you want to restart, let's say you want to restart this container, I can run restart. Click on enter. So restart command is not there. I guess reboot it is. Reboot command is not there. Let me, because this is lightweight container, means all the unnecessary binaries are removed. It's like a lightweight operating system. The operating system, the container that you are running, it has a lightweight operating system. So means all the unnecessary things are removed, only necessary things are there. You can see just binary, some files, and your application is running. Now let me show you where is the application source code. Whatever you can see here, where is the application source code? Do you want to see the application source code?
Yes.
Yeah. Yes.
Let me go here. Slash cd where, sorry, usr. Let me switch to bash terminal. If I write bash, it will go to bash. Can you see? I switched into bash. Now cd slash where, not where, usr share nginx html. So this is the folder where source code is there. Can you see this index.html file?
Yes.
Cat index.html. You can see the content. See HTML. Do you understand HTML?
Yeah.
Sandra, do you understand HTML?
Yes, okay.
See, welcome to Nginx. Welcome to Nginx is the heading. Then if you see this page, you see, if you see this page, Nginx successfully installed and working. Same content. Same content. What in case if I edit this source code? Can I edit this?
Yeah.
Yeah, so let me try editing. Nano index.html, nano not found. See, nano is there, not there. Nano is the editor. In this, nano is also not there because it is a lightweight OS. Means they have a lightweight OS in this container. Now vi, vi index.html, vi is also not there. Let's try vim index.html. Vim is also not there. Then how to write inside the file? So as I told you, we will not do any modification from the containers. First, if you want to do any changes here, you have to build a new image, then you have to run a new container. You have to build.
You mean like in our source code, we locally need to change the change, and we need to create image again.
Yes. So you have to change the source code locally, then build a new image and run a new container.
So for example, if I am having a new enhancement or a new release, each time I have to create a new image and have to create a container. Isn't
Yes,
it?
you're exactly right. So if you have a new release, you will create a new image, then you will replace the container, old container with new container. But there is a way which I can show you here. What I will do, I will run echo command. You know echo command, right?
Yes.
Yeah.
Echo is the printing statement. What I
Mm.
can do, I can redirect this into my index.html. Are you understanding? So I put double greater than symbol. What it does, it inserts the content hello into this file without editor.
Mm.
Click on enter.
Okay.
So let me check. Hello is coming here. It should be coming now. Can you see this?
Okay.
Okay.
Are you
We can
understanding?
just add as a last line only, right? We cannot able to do anything in between or.
Yeah. So because that is not the purpose of this container. Like will not directly edit the source code from the containers.
Mm.
Then, out of curiosity, I'm asking, like, is there is a way to automate the process? Like, when I'm doing enhancement or release, like everything will be happening automatically. Do we have any automation process? Like, the each time we have to, instead of creating a new image and a container, everything will be happening automatically. Is there is any latest technology? Out of curiosity only.
That is what the that is what the focus of DevOps. That is what DevOps engineer does. So whenever a developer do something, a CI/CD pipeline will trigger. In CI/CD pipeline, we will mention the steps. We will have the scripts. We will mention Docker commands. We will mention Kubernetes commands, whatever is
Okay.
required. So we'll write everything. As soon as changes comes into main or whatever the branch you have, let's say majorly main or master branch, any pull
Mhm.
request or any new update in the main branch, which will automatically trigger a CI/CD pipeline. In the CI/CD pipeline, you will write all the steps. Whenever new change comes, build a Docker image and replace the old image with new image. Sorry, replace the old container with new container.
Mm-hmm. Okay. Okay.
Right? This is an
Okay.
automated process. So to understand, to perform that automated process, you have to understand how it is working.
Okay. Got it.
Right? At the end of the day, our goal is to automate the process only.
Okay. Thank you for sharing this.
Yeah. Yeah, so now what I'm gonna do, so this is how the website is. Then I'll stop this. If you click on stop, it will stop it, right? So this is just a
Mm.
very basic pulling the image and running a small container, right? So but this is not the right way to do it. It's like, no, I'm just doing baby steps so that you understand what it is.
Okay.
Okay.
So I'm just doing baby steps here. Let's click on
Mm.
this. This is the Python application. Let me start this Python application, right? So this Python application, you don't know, I'm not sure whether you know Python or not. This is running on port number 8000. So let me click on this. You see, this is the website. Can you see this website?
Yeah.
Simple web calculator. This is the website. So this is how it runs. So same way, I just wanted here also, if I click on exec, I got inside the container. I can do ls, and this is my source code. Can you see this? app.py
Mm. Yeah.
requirement.txt. So if I do cat app.py, app.py, yeah, you can see this is what the source code I have written. And if you want to see the files, you can see the files here directly, the files and folders. If you want to see the statistics of your container, like how much CPU is being used by this container, what is the memory usage of the container, disk read write, network in and out. And if you want to see the logs of the container, you can come here. If you want to inspect it, so these are the metadata information of your container. So you can do, you can bind mount, we did not do, it's related to volume. So just I wanted to show you visually, so that whenever I run a command, you understand what command I am running. Okay,
Mm.
so this is a very developer friendly tool. This way what I did now, it is a developer friendly way, right? But usually this is not the preferred way. Will not come to Docker desktop, you will not get access to Docker desktop, we will not do anything using Docker desktop. It's very rare case. Okay, so it's very rare case.
Mm.
It is for developers, those who are not good at Docker. They are still learning, they are, they still want to do everything using UI, graphical user interface, then they go for a Docker desktop. But in in real time, we use commands for everything, for running a container, for creating the images, for building the you know for building writing your Docker file, building image, running containers, deleting containers, for everything, getting inside the container, running command inside, getting the statistics of the container, everything we run commands, right? So how do I do that? So for that, let me show you. First you have to open terminal from your machine. So let me open terminal. So terminal in the sense, terminal cmd, command prompt. For you it is terminal if you're using Mac. If it is Windows, open command prompt, PowerShell, Git bash, anything is fine.
Then what is the use of WSL? Installing of WSL in Docker?
Without WSL, Docker will not run. Why?
Okay.
Initially Docker was developed for Linux machines. Okay, the Docker works only on Linux like environments. Now Docker
Okay,
desktop is running on Windows because of the WSL. WSL gives a virtual platform for Windows to run Linux ecosystem. It is, the name itself is saying Windows subsystem for Linux. Windows subsystem for Linux means WSL is nothing but a Linux platform for Windows.
Okay.
Without that, Docker will not run. So now let's do Docker ps. See, this is the command to list the containers, running containers. To list the running containers, if I do, see, my Python is running, right? My Python app was running. See, py app. See, this is the container ID. This is the image which is used to create this container, and this is the command running inside the container, and it is created 6 days ago and running from last 4 minutes, and which is running on port number 8000 of local machine, container port number 5000. Then Python app. The name of the container is Python app, and I have some containers which are not running, which are in stopped state. You have to do docker ps-a to see all the containers irrespective of their state, whether it is running or not. Can you see this?
Yeah.
So this is the Python container, and this is some different container. Okay, so docker ps-a is the command to list all the containers, running, stopped containers, all state of containers. Okay, fine. Now I am running a container. The container name is pyapp, correct?
Yeah.
Docker logs pyapp to get the logs of the container. So manually, using graphical user interface, I was taking like this. I was going inside this. I click on logs to see the logs, correct? The logs which are visible here, I can see in the terminal directly using this command. Docker logs pyapp is the container name. Easy?
Yeah.
Yeah. If you want to stop the container, docker stop pyapp, enter. Stopped the container. See, stopped it. Docker ps-a to see all the containers. You see Python app, pyapp, which is in stopped state. You see exited 9 seconds ago. 9 seconds ago it stopped. So now how to start it? Docker start, then pyapp, py underscore app, enter. Started. How to see the running containers? If you want running containers, docker ps, enter. You see it is running. Can you see this? It is running. Now I'm just playing with the container which is running. Okay, if you want to get inside the container, you can do like this: docker exec hyphen it interactive mode execute this execute hyphen it py app, then get inside the bash. Are you understanding this? What is this? I was going inside this container. I was click on exec, then write bash here to get into bash. Correct?
Yeah.
Instead of doing this using GUI, I'm doing it here in the terminal. If I click on enter, you see I got inside the, means my terminal, local terminal is attached to container now. You see? Correct?
Yeah.
Sandra, I hope you're understanding.
Yes, yes.
Yes. So this is how we do it. Next, I'll exit from this container. If you want to exit. See, I exited from the container. Now, let's say, CLS it is command prompt. Docker PS container is running. How to stop it? Docker stop. Let's say I want to remove this container, delete this container. Can I delete this container? Is it possible?
Yes.
Yeah.
How? Docker rm -f for force, because it is running. When a container is running, you will not be able to delete it. You have to force it. Right? So py app py underscore app enter. Deleted. So if you do docker ps, container is not running. Easy.
Yeah.
Now, how to see the images? If you want to see the images, docker images, run this command. See, there are many images which we have downloaded. Are you understanding?
Yes.
In this, which image which we used? We used this Nginx Perl, and there was one application which was running with this.
Okay.
Right? You can see Nginx Perl here. And the size of this image is 930 MB. Size of the Nginx image, Nginx Perl. Now, if you want to create a container using this, how do I create a container? Observe very carefully. Docker run -p. -p stands for port. -p stands for port. Port number 90:80. Do you understand what is this 90 and 80?
Host port and
Container port.
That's it. So -p host port, container port, -- name. Then you have to name your container. What is the name of my container? Let's say Perl container. Shall I give it as Perl box? What is this? What is this?
Container name.
container name.
Very good. Next, what is the image which I want to run? What is the image name? This is the image name.
Okay.
Image name always at the last. Image name always at the last. Then container name before that. Then port number. Then click on enter. It will create a container. See, container created, and the logs are running directly on the terminal. Yes or no?
Yes. Yeah.
So now let me go back to port number 90 and refresh. Yes, you see it's running. Now terminal is attached to container. You see logs, log entry. Somebody is accessed from Mozilla Windows NT 64. This is the log. Get request. Right? This is running directly on the terminal. How to detach it? Control C. See, detached it. Means I disconnected the terminal. If you go back and if you run docker ps, you see container is not running. As soon as I exit from the terminal, container stopped. It's in stopped state. Let me show you. You see, it's in stopped state. Perl box. Can you see this?
Yeah.
It's in stopped state. The reason is I was running the container on interactive mode. Means the terminal was my laptop, the host terminal was attached to container terminal. As soon as I exit from the terminal, container stopped. So what you have to do when you are running this container, when you are running this command docker run and this, when you are running this command, you have to mention -d. What is this? Detached
Yes.
mode. It runs the container in the background without attaching my terminal. I hope you're understanding what it is. -d runs the container in detached mode. I'll show you how it runs. You see Perl box 2. I'm running one more container. Same image. Port number is 99. I'm using the port number 99. Then Perl box 2 is the container name. Then this is the same image. Let me click on enter. See, container created. It is just giving the container ID. Last time when I created the container, the terminal was attached. These logs were coming directly on the terminal. This time not coming because I'm running it on detached mode. I hope you're understanding this. Detached mode in the sense it is running in the background. You see docker ps. Is it running in the background? Perl box 2.
Yes.
Is it running in the background?
Yeah. Yes.
It is running in the background. So now let me go back to port number 90. So if I go here, localhost port number 99, enter. Welcome to Nginx. If I want to see the logs of this container, how to get the logs? Docker logs
Logs.
Perl hyphen box
Box
2. Logs are coming. If I want to get inside the container, what is the command? Docker exec exec hyphen it. Then what is the command? Perl hyphen box 2. Then I want to get inside the bash. Enter. You see I'm inside the container. I can do ls here. I can create the files. I can do the stuff. I hope you're understanding.
Yes.
Yes.
Any confusions? Any confusions?
I just like how like this is an existing Docker hub, right? But we used is Nginx.
Images, yeah.
Yeah, this is an so when you create that Python, how did you created that one, the Docker file?
Yes, the Docker file we'll discuss tomorrow. For that, there is a
Okay,
Docker file which I have written in my local machine. It's there.
okay.
So the Docker file, using the Docker file, I have to build the image. Let me show you. I guess it is there somewhere here. Infra contribution. Where did I write? I'm not sure. Maybe this one project. Not this one. Somewhere I wrote it. Not sure where it is. Okay, it's not there. Tomorrow I'll show you how to
Okay.
Okay,
create
yeah.
the source code. Somewhere I kept it. I'm not sure where did I put. But it is, I guess, in the infra folder. Not Terraform module is there. It's not there. So tomorrow I'll show you.
Okay, yeah.
Yeah. So you have to create the Docker file on your local machine. First, you should get the source code for that. That's why I told you you create your own application. We will make it as a container. So
Okay.
this is how you do it. So now if you want to pull a new image, let's say I want to pull a new image. So how do you pull it? See, I'm inside the container. First I have to exit from here. If you want to pull a new image, so how do you pull it? So if you want to pull a new image, you have to pull using docker pull image name nginx. So let's say I want to pull nginx perl. You can write like this. So what it does, it pulls the image. So where do you get this name? First you have to go and select your in the Docker hub. You have to search.
Docker hub.
Let's say Let's say for Java I need OpenJDK, so I can search for OpenJDK image. OpenJDK it is.
That's correct.
OpenJDK. Yeah. See, this is the image. Are you understanding? This is the image.
Yeah.
If I want to pull this image, how I can pull? See, let's say I want to pull Java JDK 14 Oracle 14 Slim. These are the different versions of JDK. You see, 13 JDK, 14 JDK, they have different versions. So let me pull. Okay, anything is fine. I'll just go for this. I'll pull this image. How do you pull this image? Either you can do pull from directly here, or else docker pull OpenJDK. OpenJDK. Then in OpenJDK, which version? You have to mention 27-EA-slim. 27-EA-
Slim.
So it is pulling the image. It is pulling the image. Image is heavy. It takes some time. So it pulls this image. Then I can create a container. Now, see, OpenJDK is just a tool. It's just a Java, right? So if you create a container out of this image, container will not run. As soon as you create a container, container will go in stopped state. Container will go in excited state. Why it goes on excited? Because there is nothing actively running. Java is just a tool, right? What is nothing? No process actively running. So it will just go to excited state. It will stop the container. So what to do? Using this image, this will consider as a base image. Using this image, we will customize to our application. So on top of this image, we will add the source code, we will do configurations, then we will make new image which runs our Java application. Okay, so tomorrow I'll show you how to customize the images, how you can containerize your applications, how to write a Docker file, and many things. So today I just told you how you can, just a visualization, small intro to how container works, how to create the container, and how to deal with the containers using UI and terminal. Tomorrow I'm going to show you how to create Docker file, how things works internally in Docker, and all of this stuffs. So today what you have to do, it is mandatory that you have to go to your Docker hub, open Docker desktop, you have to run containers, you have to run this command.